So I just want to follow that up with talking about React class components and being able to distinguish between building our components as functional components versus building our components as class components. So we'll talk about class components, inheritance in React, constructor and props, instance variables, and the property of state, inherited methods with the setState method, inherited methods with the render method, composition and components of React components, so how we can use components to build other components, which we've already seen before, and we'll more explicitly talk about the component lifecycle. So before I move on to this, is everyone pretty much good with the functional components? At least with what we've lectured about? Perfect. So now I want to compare and contrast. So class components. Components are independent and reusable bits of code. We've seen that previously, but that's worth mentioning because this opts for a very object-oriented approach, right? So they serve the same purpose as JavaScript functions, but work in isolation and return HTML via a render function. That HTML is actually JSX, which is an HTML-like syntax. Components come in two types, class components and function components. And in this lecture now, we will concentrate on the class components. So class components use class-based syntax and an OOP approach as opposed to a functional approach in designing our interface. So for the class-based components, we will use inheritance. The React library has an abstract class for component. A class component must extend from the React component class so that your new components inherit all of the components built into the React functionality. And so the class component also requires a render method. This method returns the HTML. It's really JSX, HTML-like syntax, but it looks very much like HTML. So a quick example of what a class component would look like would be this. I define some class, let's say it's car. And again, the reason, because these components are both class and functional at the same time in the library, is why our class components or our functional components always start with uppercase letter. So we're creating a class called car. Now, since this is a class, then we must inherit. So we're going to extend React component. So from React is a component. And so our car will be a more specific type of component from the generic component. And so every component must implement a render function. The render function is the thing that returns the JSX. So here I will return the JSX. So for some of you, it just might be more natural to think of React in terms of classes as opposed to functional, because that's what you've been trained to do. But it's important to understand that you can do it in both ways. So this looks much more similar to Java, doesn't it? Okay, so let's talk about the constructor and props. So if there is a constructor function in your component, notice here we did not use a constructor component because we just used the default constructor, which is fine. Then we just have to implement a render. But if there's statefulness you want to maintain, then you might want to go ahead and define a explicit constructor. So if you define a constructor in your component, this function will be called when the component gets initialized, right? So whenever, and what that simply means is whenever you have JSX that is using that function, that class component's name, that's the same as invoking the constructor. The constructor function is where you initiate the component's properties. Yep, that's what we already know about constructors. In React, component properties should be kept in an object called the state. So all of our instance variables have to be inside of a property called state, inside of a state object. And that's by the design. That's an expectation of a React component. So that is a design pattern we must follow, and you'll see that in just a bit. And then the constructor function is also where you honor the inheritance of the parent component by including the super statement, just like we've learned how to do with inheritance, which executes the parent's component constructor function, and your component has access to all the functions of the parent component. So an example of using a constructor where we do maintain some kind of state. Here is our class definition, car. We have to extend off of the React component. We can define a constructor explicitly. Whenever we define a constructor and don't use the default constructor, we have to always invoke the super keyword. And then here, if we want to have a statefulness, we could do this dot state. We have to call it state, and then whatever the actual values of the properties of this particular component will be embedded inside this object. So suppose you have the attribute color, you can set to red. And then we have to have that render method that returns your JSX. Inside of our JSX, looks just like HTML, we could dereference our instance variables from there. So from this dot state dot color, and then this would say, I am a red car. Again, this looks exactly like, it's not very different from like what we did with the platformer game, what we did like in the 4th week of classes. So building class components should be something you're already familiar with syntactically. So React props, let's talk about these props. React props are like function arguments in JavaScript, and they're like attributes in HTML. So props are how you pass data from one component to another as parameters. Props are arguments that are passed into React components. Props are passed into components via HTML attributes. Props are read-only. So to send props into a component, use the same syntax as HTML. So this is similar to what I've already showed you with React. So in this instance, suppose that we go ahead and create my element. This is the JSX. So when I create what looks like this HTML syntax with car, which is a React component, and then I have attributes, which has the name and then the value, right? That is the property. And so inside of the actual JavaScript code, when we create our class car, which extends from React component, inside my my constructor now, if I'm going to expect properties, I will have a props object, and all of the attributes that are defined inside of the JSX will be bundled into one props object. Now, it's important when we're using these class components that if you expect a props in your constructor to pass that to the parent constructor as well, because that's where it actually gets saved into. So it's the parent constructor that's responsible for maintaining the properties. And then in our render function, we can access our properties just by doing this.props, and then whatever the value is inside of the property object. In this instance is brand. So the props should always be passed to the constructor and also to the React component via the super method. Okay, so a quick example of what this might look like, an example 2. Suppose here, so right here, when we passed in props, we passed in a string literal, but suppose we wanted to use a variable. Well, it might look like this, though. This is the entire source code. So suppose I have here, this is actually using composition as well. Suppose I have my class component car, which extends a React component and has a render method, which is going to use this.props.brand. Now, by default, the constructor, the default constructor, if we don't override the constructor, then it already takes in a props instance and binds it to your instance. So by default, if we don't create a constructor, we already have access to this props object. So let's say we have another component called garage that extends React component. Inside its render function, we might go ahead and call car name. So we might create a car name, which is a variable. And so when we actually do our return in our render function, we create our JSX. And so when I go ahead and use my JSX to embed or render a particular car element, when I go and say I want to add a brand, I can use the curly braces in JSX to access pure JavaScript. So here I can dereference the value of a variable, just like that. Excellent. And so this is a way of passing data in as a property as literal values or as variables. So let's talk about that state. It's just variables and that state property. So React components have a built-in state object. The state object is where you store the property values that belong to the component. When the state object changes, the component re-renders. So that's the important thing. Whenever you want, so like for that button click example I gave earlier, that only re-rendered the view every time the setState method got called, and the same with class components as well. So the state object is initialized in the constructor, and the state object can contain as many properties as you like. And so here's just another example of how we can define state. So we already saw this previously. This is just an example that has more attributes or more properties. So inside of here, we have class car that extends a React component. I have a constructor that takes in properties. I pass those properties to the parent class. And then I can have instance variables. One instance variable I can have that I should have based off of the way that React is designed is a state instance variable. But inside the state instance variable, the state object, I can embed any number of custom attributes I want, such as brand or model or color. And then I have my render method. So here I'm just not using the state. But this is an example of how I would go ahead and define it. Okay, so suppose I want to access the state. So you can access the state object anywhere inside the component instance by using the syntax this. So obviously the this keyword. And then inside of this instance is a state object. Inside that state object is your property name. So it's just like we've already learned how to dereference instance variables from objects. And so an example of this is, imagine if I still had that same code. So I have class car that extends a React component. Inside the constructor, I pass in my props. I send those props over to the parent class. Inside of my instance variable state, I have the object, the state object. And then let's say inside the render method, I want to access some of these properties. Well, I could go ahead and using curly braces inside my JSX, be able to access my the actual JavaScript. Now, it's important to state, if I had other methods, I can define, this is a normal class, so I can have more methods than just constructor and render. I can create another method that's just pure JavaScript. So the only time I need to use these curly braces to access JavaScript elements is when it's in the JSX. So JSX is when I'm using the curly braces. But if I created some other function, let's call this function, for instance, let me copy this so I get syntax highlighting. So let's say I had this other function foo. I could do something like this, console.log, and then let me grab that. Okay, so notice I don't need the curly braces here because I'm in pure JavaScript. I'm not in JSX. So at any point inside of the instance, I would use the typical syntax. This dot state dot whatever I want to access. But in JSX, I would do it inside curly braces. But simple enough. Okay, so let's talk a little bit about these inherited methods. So you get two inherited methods when two that we really care about. You get more than two, but the ones that you should really be concerned about when you go ahead and extend off of a React component is the setState method, because that allows you to re-render the state of your class component. Now, the big thing is, despite the fact your class component has a render method, you are not allowed. That's a protected method. It's a private method. It's a method you cannot invoke explicitly. It's a method that only gets invoked by the React runtime manager, essentially. So React gets to decide when the render method gets invoked, and you can cause the React to invoke a render method when you either initialize a component, so when you instantiate it, or when you invoke the setState method. Those are the only two times that you can really effectively have React invoke render. You can't explicitly call it. And so setChange is the method we have to use to change a property into state. Now, yes, you can change the state without setState. You do have access to it. You could just dereference it and assign a new value in there. But if you do that, React will not render the new state of that component because it doesn't know you changed it. Essentially, it's looking for setState to get triggered to be invoked to know that the state of that component changed. So you only ever want to change the state of any of your attributes using the setState function. I hope I'm super clear with that. Like I can't repeat it any more times than that. Like, always use setState to change or mutate the state of your component. So to change the value in the state object, use the this.setState method. When a value in the state object changes, the component will re-render, meaning that the output will change according to the new values. Always use the setState method to change the state object. It will ensure that the component knows it's been updated and calls the render method, and all other life cycles of the method as well. So just a quick example of how this might look. Suppose that I have this class car that extends the React component. I have the constructor. I have a change color method now where I'm going to call this.setState, and I'm going to notice what I'm doing inside of setState is I'm passing an object itself that has one of the properties I want to set, even if it's a pre-existing property, and then the new value for it. So when I do this, it's not going to change the state to only have color. It's going to look for the color attribute or property and just change that to blue. So you'll still have brand Ford. You'll still have model Mustang. You'll still have year 1964. But in addition to that, you'll also have mutated color from red to blue. So that's the important thing about setState is it will look at, and if it's a new attribute, then it will add that attribute to the state. So you can either mutate a state or add an attribute, but this will not overwrite your state object with setState. So again, this is an inherited method. We did not define it, so you just have to understand what the behavior of it is. So then in our render method here, we can go ahead and see that on a click. So let's see what's happening here. I have my div in my JSX. I'm going to create a heading element that's going to show and it's going to dereference this state, from my state object, the brand of the car. And then inside of the paragraph element, it's going to say it is a, and then I'm going to dereference the color of the car, the model of the car, and the year of the car. But I'm going to create a button element. I'm going to give it a type button, and then I'm going to give it an on-click property. And notice I can bind the on-click behavior by passing a reference of the function, right? So I have this function. So in curly braces, it's this dot change color, just very similar to how we would do this in pure JavaScript. And then this would cause the setState. So when you click this button, it would actually cause the component to update after the click because the setState method was invoked. So let's talk about the inherited method of render. So React invokes each component render method whenever it is initialized, or its setState method. Set, that doesn't make sense. Its setState method is invoked. Every class component should have a render method. The render method must return the JSX, that HTML-like syntax of the component, and the return JSX must be in a single 8 JSX element. However, it may contain any number of child elements. We've already covered this before. And so this is just an example of how we might use composition. Again, we've already seen this, where we can take and define a car component, and then another component like garage can contain a car component. And so when we go ahead and render garage, it is also going to render a car. So classic composition. So nice thing about React, it uses all the object-oriented things: inheritance, polymorphism, composition. So the last thing I want to cover over React, we've talked about functional components. We've talked about class components now. Let's just talk a little bit about the component lifestyle. So each component in React has a life cycle, which you can monitor and manipulate during its 3 main phases. So the 3 main phases of a React component is the mounting phase, the updating phase, and the unmounting phase. So mounting just means that you put the elements into the DOM. React has 4 built-in methods that can get called in this order when mounting a component. It invokes a constructor, then it invokes a method called get derived state from props, then it calls a method called render, and then it calls a method component did mount. So the render method is required and will always be called. The others are optional and will be called if you define them. So again, these are the methods that React will try to invoke if they exist inside of your, if you explicitly define them inside of your component. So the constructor, it's just a method that's called before anything else when the component is initiated. So we kind of know what a constructor is. So we're going to move on from there. So get derived state from props. This is a method that's called right before rendering the elements in the DOM. This is the natural place to set the state object based on the initial properties. So it takes state as an argument and returns an object which changes the state. Again, this is optional, and you might not use it very often, but it's nice to know that it exists at least. The render method, we know what it does. And then finally, the component mount. The component mount method is called after the component is rendered. And this is where you run statements that require the component to already be placed in the DOM for them to execute. So again, these methods can be used for effectively event-based triggers for when a component actually exists inside the DOM. Let's talk about the updating phase during the component cycle. The next phase in the life cycle is when a component is updated. A component is updated whenever there is a change in the component state or properties. React has 5 built-in methods that get called in this order when a component is updated. Get derived state from props, should component update, render, get snapshot before update, and component did update. And again, the render method is the one important one. So again, the important concept behind this is when you first create a component, the constructor gets involved, and then the render method, or every time it gets updated, it calls the render method. But we'll quickly describe what these other 4 properties are, these 4 methods. So get derived state from props. Also at updates, the get derived state from props method is called. This is the first method is called when a component gets updated. This is still just a natural place where you would set the state object based on initial props. So instead of putting it in the constructor, you can put it in here in the get derived state from props. But I typically just put it in the constructors as well. Should component update, this returns a Boolean value. The return value is yes, but you might have logic that you don't want the component to update when the state is changed. You might want to maintain the original rendering, just change the state, and then you actually render. Then you get a snapshot before update. And then finally, the component did update. And again, this will trigger any actions where you need to have your behaviors operate after the DOM elements have rendered. And then the final and last thing that happens in the life cycle is unmounting. And so here, the next phase in the life cycle and the final stage is when you remove a component from the DOM, or unmount, as React likes to call it. React has only one built-in method that gets called when a component is unmounted. Component will unmount. And so this method is called when the component is about to be removed from the DOM. And then you can put whatever behaviors you want to do cleanup work in here that might need to happen. And that's it. That is a quick crash course in React, and you've learned how to implement React components and maintain or access the state of React components as both class components and as functional components. So with that said, is there any questions? Or does this, at least from the presentation, does this make sense? So let me ask you this before we close out today's lecture. Do you, based off of what you've seen in the slides, prefer the syntax that is class-based or function-based? Yeah, and that's fair. It's and I think it's, yeah, you're right. Function, and that's exactly why I think they're pivoting towards really prioritizing the function base. Is that there's always that strive to try to minimize statefulness. So in a functional approach, usually you'll have like a data store, and the reason why web dev is typically thought of as more function-based, like that's a very good observation. And the reason why that's the case is that understand that first of all, HTTP is it's a stateless protocol. But it's not just that. It's I don't know what's happening here with my computer. Cancel that. Okay, it's not just that though. It's that most of the statefulness of a web application exists inside of a database. And so typically in a functional architecture, you still have to maintain state. Like, you can't get away from having some concept of state somewhere in your system, but the idea is you aggregate all the state together, and then all the processing that occurs inside of your application is designed to try to be as stateless as possible, so that you can chain series of function calls together, and you pull whatever you're maintaining out of a data store, you pass it in, you get the new values, and you put it back in some other data store. And so that concept melds very well with web applications, where the concept of where we store our data is in a database, right? Whereas in a traditional application, we have access to be able to just store things locally in memory at any time. So object-orientedness makes a lot of sense. We can just create individual objects that contain behaviors and also maintain their own statefulness. But sometimes having various elements of your software application that all have their own independent state can add additional complexities to a software system. And so sometimes it's beneficial to try to wrangle the state out of the objects themselves, out of the entities themselves, and aggregate it all into a data store. Anyway, with that said, I will end this lecture if there's no other comments or whatnot, and I will see everyone on Thursday, the penultimate lecture day.